Just a small remark. Omega 1, according to our definition, is omega 2, 3, right? So it will be half du3 dx2 minus du2 dx3. And omega 2 is just omega 3, 1. So it will be half du1 dx3 minus du3 dx1. By the way, have you gotten the idea? Where do we have a positive omega or a negative omega? Well, let's just say, is it omega 3, 1 that equals to omega 2, or omega 1, 3 that equals to omega 2? Do you get the idea? Well, it's according to the permutation, right? Permutation. So what indices the capital omega takes, the lowercase omega will have the other index, right? So if the index of the lowercase omega and the capital omega and the two indices of the capital omega will form a clockwise permutation. Say here 1, 2, 3, or here 2, 3, 1, right? 1, 2, 3, 2, 3, 1. Then we will have, they will be of the same sign. But if they will form a counterclockwise permutation, then they will have the minus sign. Say 2, 1, 3, right? 2, 1, 3. This will be a counterclockwise permutation. So omega 2 will equal to minus omega 1, 3. Okay, so the other one is omega 3, which we have already know. Or you can say omega 3, what will be the entry of the capital omega that will have the same sign as the lowercase omega 3? 3, 1, 2, right? So omega 3 will equal to omega 1, 2. This thing we have written out before, so I guess you are very familiar with du1 dx2. Okay, so it seems that we can define a omega vector, right? A omega vector will have three components: omega 1, omega 2, omega 3, or you can say it's ei times omega I. And I claim that this thing is equal to half the curl. The omega vector is equal to half the curl of the velocity. Okay, so omega, sometimes we define it to be the vorticity. You are welcome to check that this thing, and this thing will give you the same result, okay? So this is one thing. Another thing, now we can break down the movement of any fluids, right? Or any movement of any fluids. When the location has experienced a small change, what will happen? How can we represent the velocity here? The velocity here by the velocity here. We need to incorporate the effect of all the three components, right? The translation, the rotation, and the deformation.